Okay, pre-calculus students, we're going to try to do this video one more time. I'm using my iPhone, so it's got some limitations. Okay, so I'm going to be explaining numbers 41, 47, 53, and 65. The first one, 41, in fact, most of these require us to know this formula, which says, and it's on page 435 and page 436, it says that the cosine of an angle is equal to u dot v, and this is the angle between directed line segments u and v, also known as vectors u and v. So the cosine is equal to u dot v over the magnitude of u times the magnitude of v. And we're going to be making use of a transformation of this equation. I could get u dot v by itself by multiplying both sides by the magnitude of u times the magnitude of v. So that would look like this. U dot v is equal to the magnitude of u times the magnitude of v times the cosine of theta. And in fact, that's on the top of page 436. And that's the formula we're going to use for number 41. So that's the formula, and they tell us on number 41 that the magnitude of u is equal to 4 and the magnitude of v is equal to 10. And they also tell us that theta is 2 pi over 3. Now 2 pi over 3 is 120 degrees. That puts us in quadrant 2. So 120 degree angle, it's like a 60 degree angle drawn in the second quadrant, and this short side would be -1/2, and the long side is the square root of 3 over 2. But I want this one because we're looking for the cosine. So u dot v is going to be equal to 4 times 10 times the cosine of 2 pi over 3. And I already know the cosine of 2 pi over 3 is -1/2, so I'm saying 40 times -1/2, which is -20, which I checked in the back in the book, and yes, that's the correct answer. Okay, and so now I'm done with number 41. Before I do 47, it's going to ask me whether two vectors are parallel or orthogonal or neither. And so I've drawn two vectors. Specifically, I drew them so that they would be parallel. Now they're not the same size, they're not the same magnitude, and they're not facing the same direction, but that doesn't really matter. So I'm going to write this in component form and the component form for this vector. So in this case, it's going 2 to the right, so that's a 2, and 1 up. So that's component form 2, 1. Component form on this one, it's going 4 to the left and down 2, so that's what we get. Now if we compare the x's here, if I were to take this x and multiply by -2, I would get -4. If I take this y and multiply, and it's actually changing y, it's the horizontal component, and multiplied it times -2, I would get this value. Since they're being multiplied by the same value, that tells me that the two directed line segments are parallel. Okay, so now let's look at number 47. The reason we're looking at 47 is because it deals with the idea of whether it's orthogonal or not. And we find out by reading in the book on around page 436, I think it is 436, it says if the dot product of two vectors is equal to 0, then the two line segments, the two directed line segments are perpendicular. So in this case, they tell us that the component form of u, on number 47, is 1020, and the component form of v, and you'll see why I'm writing it over this in a moment, is -18.9. Now, I'm looking at these, and I'm thinking, what would I have to multiply 10 by to get -18? It would take -1.8 There is no way 20 times negative 1.8 is going to get me 9. So these are not parallel. Okay? And 20 times 20 ninths is going to give me 9. But in fact, that's why I wrote them this way, is because I could just do a ratio and compare the ratios. Well, this one would be negative, this one's positive, so that therefore they can't be parallel because they're different signs. But they're also different numbers, so it's not parallel. So my other choice is that they're orthogonal. And if they're orthogonal, then their dot product, 10 times negative 18 plus 20 times 9, would have to equal 0. And in this case, I think they do. We get negative 180 plus 180. Lo and behold, it does equal 0. Therefore, it's not parallel, but it is orthogonal. And orthogonal simply means forms a right angle. Okay, moving on. Let's look at number 53 now. And number 53 says, I've got these two vectors, and I want to solve this problem in such a way that the two vectors are orthogonal. And the way to do that is to write the dot product as equal to 0 and solve for the missing variable. In this case, it's going to be k. So that's a 1. So the dot product would be 1 times 7k is equal to 4 times negative 5. So in this case, I get 7k minus 20 equals 0, which means 7k is equal to 20, and that means k is equal to 20 over 7, which if you had the teacher's edition, you'd find out that's the correct answer. Actually, it's in the student edition too, because these are all odd problems. Number 65 says, now we're just given one vector, u, in component form is 2, 6. So we need another vector. Actually, we need two vectors that will be orthogonal to this one. Well, in order for them to be orthogonal, then I have to have their dot product equals 0. So now I want to think about two numbers that I can put in these parentheses, and it can be any two numbers that will make this equal to 0, other than 0, because that won't give me two vectors, it'll only give me one. So in this case, an easy choice would be to put a negative 3 in here and a 1 in there. So one of the vectors that will work is negative 3, 1. Let's check and see if that's right. I'm going to get negative 6 and 6. Yep, that'll work. But it also says get one that's opposite to that. Well, opposite means going the opposite direction. Instead of 3 to the left, we're going to go 3 to the right. Instead of going up 1, we're going to go down 1. Now, if I put a negative 1 in here and a 3 in here, do I also get 0? And yeah, we do. We get 6 here and negative 6 there. That's going to be equal to 0. So there's our two answers. And that's how you do number 65. And likewise, how you would do number 66 and 68.